Hello everyone, in this video we will be learning about Gauss divergence theorem. Here before we have studied about the Green's theorem, then Stokes theorem. Now we will be learning about Gauss divergence theorem. Like here in the Green's theorem we have seen the relationship between line integral and double integration. In the Stokes theorem we have learned about relationship between line integral and surface integral. Similarly, here in the divergence theorem we will be learning about the relationship between the surface integral and the divergence and the volume integral. So, this is the relationship we will be learning here in this theorem. So, what it does, it tell as per the statement, what it tell, if you find the surface integral of vector point function, which is nothing but f vector, we denote it. If you take its surface integration and along the closed surface, this is nothing but S, which we have pointed over here, then that will be equal to the volume integral. If you take the volume integral of that vector function over the volume which is bounded by that surface which is S. So, that is equivalent to that one. So, mathematically how we represent it, this is nothing but the f is nothing but the vector point function, and we will be taking its surface integral of it over a closed surface which is nothing but S. That will be equivalent if you find the volume integral of that vector point function over this closed volume which will be bounded by that surface which is S. Those are, both of them are equivalent. That is how it mathematically we can write it over here. Now, what is here we know that n cap is nothing but the unit vector which is normal vector which is to the given surface. Now, if you look at the question, it will be clear, like here if V is the volume enclosed by closed surface S and F is a given vector point function, then what we have to show it, F into n cap into ds is equal to 6 V. So, first of all we will start first of all we will be write the given vector function as it is. We will be taking its a divergence. We know that how we take divergence is we take the del and we take the dot product with the f vector. Del operator, this is the first bracket, I have written the value of del here, and the given function I written here in the second bracket. Then we will be start taking the multiplication, like I along with I whatever we are getting we will multiply together, then with the j del by del y into 2y, and with the z we will be taking del by del z and with the 3z. So, k के साथ k cap के साथ जो भी आएगा उसका product हमने ले लिया यहाँ पे. So, if you start solving this, then you will be getting this answer which is nothing but 6. Then by divergence theorem, what does divergence theorem says? If you take surface integral of vector point function over a closed surface, then it will be equal to vector integral volume integral of given function vector point function over the closed surface over the closed volume which is covered by that surface. So, nothing but this is the volume integral, it's divergent of f which we already got it over here 6. So, that we have to take it. If you integrate it, then you will get 6 V, and this is what they ask you to prove it. We have to find what they ask you to prove it is f into n cap into ds is equal to 6 volt. We have taken here by using the Gauss divergence theorem, we have found here the right hand side which is coming to 6 volts. So, that is why we can say that f vector into n cap into ds is also equal to 6 volt. This is how we have used the Gauss divergence theorem to show the relationship between surface integral and volume integral. It is very similar to what we have seen in the previous theorems, which is Green theorems and Stokes theorems. this is the very similar to that one. Thank you.